Now we will see the potential energy in an external field. So that is a kind of work done you required to assemble the number of electric charges. So how much work done you have to do, and all that work done is going to save in the form of energy. So first of all, we will see it for a single charge. So while calculating it, first we will just assume that there is one space. Just we consider that this is the region. In this there is one space, isolated space, and we will consider, let there is some potential because of some electric field is already present over here, and you have to bring, let the charge q from infinity to one particular point. Let that point is nothing but at a distance r from the source of that your charge. So this is q is nothing but the source, and that source is going to produce the electric field around it. Now we know that potential is nothing but work done per unit charge. So this work done is equals to your V into Q. This V is nothing but the potential due to this Q, that is mainly because of your source at a distance R. So you can write down this as a V of R into Q. So this work done will save in the form of energy, and that we are calling it as a potential energy due to a single point charge. So basically we are bringing that point charge from infinity at a particular point in a region where there is already the field is present, and you have to do some work to bring that charge from infinity to at that particular point. So we just assume that that particular point is at a distance r from this source charge. So you have to do some work, and that work done will save in the form of energy. So this W you can now call as a energy, and which is V of R into Q. So that is nothing but the potential energy due to a single charge. The same thing you can just see over here. So this is nothing but your source charge, and which is going to produce the external, that electric field. And whenever you have to brought some external charge in the vicinity of this, you have to do some work. So that work done will save in the form of energy. Now we will see it for two charges. I just assume that this is the region in the space, and I have to brought two charges q1 and q2 from infinity to the respective locations. For example, let it is nothing but A and B. So at A and B, the potential is nothing but respectively V of R1 and V of R2. So I will just do it one by one. First I will bring the charge q1. So while bringing the charge q1, you have to do some work, and that work done is nothing but obviously which is q1 into V of R1. Then similarly this q2 have to bring to the point B, and while moving it to the point B, you have to do some work against the external electric field. So that external electric field obviously is present over there, which produces the potential, and we are calling it as a q2 into V of R2. So these are nothing but the work done that we are doing against the external electric field. Now once I brought this charge q1 over there, so definitely this q1 is going to produce its own electric field, and it doesn't allow this q2 to move up to this point B. So definitely this q2 has to do some work, or it has to overcome the potential which is produced by q1. So in that case you can write down this as a potential which is work done per unit charge. Then this V into Q is nothing but your W. So V1 into Q2 you will write it down. So V1 is nothing but the potential due to the Q1, which is nothing but Q1 upon 4 pi epsilon naught R12 and multiply by Q2. So this is nothing but the work done, and that work done will save in the form of energy. So you have to just finally add all this your work done, and that work done will save in the form of energy. So this is how you can just explain that potential energy because of two charges in presence of some external field.